There are three common sources of water supply for fire pump activities. All three are used by both municipal and rural fire departments. The first source is the water supply from the tank mounted on the apparatus. If more water is required than is available from the tank, other sources, including fire hydrants and static sources used for drafting, will need to be used. As a driver-operator, you will be required to know how to operate the fire pump using each of these three water supply sources. Your ability to operate the pump in a manner that will provide the necessary water supply while maintaining the mechanical soundness of the pump is an important function of your job. In this program, you will see demonstrations of pump operations using each of the three water sources. The training objectives are to show how to operate the pump using the water on the apparatus, an external pressurized water supply, and water from a draft source. Most pumping apparatus have a tank that will provide water for the initial attack. Many fires can be controlled by the amount of water carried in the tank. But if the fire progresses and additional water is required, the pump operator must be able to smoothly make the transition to an incoming water supply. When operating the pump using the water in the apparatus, you need to know how to put the pump into gear, put the pump into operation, and make the transition to an external water supply if it becomes necessary. Once you have positioned the pumper, set the parking brake. The sequence of steps for putting a fire pump into gear and getting water to the pump may vary according to department policy and apparatus design. And the location and type of pump will determine the specific steps you will use. Power takeoff or PTO pumps have shifting levers that may be mounted on the floorboard or the instrument panel in the cab. Front-mounted pumps have a clutch between the pump and the motor and usually must be operated at the front of the apparatus. Let's look at the steps required to place a front-mounted pump into gear for stationary operation with a manual transmission. Bring the apparatus to a full stop and set the brake. Disengage the clutch, put the transmission in neutral, and lock it in place. Get out of the cab and set the wheel chocks. At the front of the apparatus, operate the shift lever to mesh the gears. Once the pump is engaged, an indicator light on the dashboard should light up. For stationary operation with an automatic transmission, you will bring the apparatus to a full stop and set the brake. Put the transmission into the gear recommended by the manufacturer. Set the wheel chocks. Operate the pump control on the front of the pump. When the pump is engaged, look for a light on the dashboard. The vehicle should not be moving. To disengage front-mounted or PTO pumps, you need to use the throttle control to reduce the engine to idle speed. Disengage the clutch on manual transmissions or put automatic transmissions into neutral. Move the pump control lever in the opposite direction that you used to engage it. The light on the dash should go out. Most midship mounted pumps require that both the pump and truck transmissions be in gear for operation. This transfers the engine power to the pump instead of to the drive wheels. For manual transmissions, after you have stopped, disengage the clutch and set the parking brake. Allow the engine to idle. Operate the pump shift control to transfer power from the drive axle to the pump drive. Now, place the drive transmission in the proper gear as shown in the apparatus operator's manual and lock the lever in place. Slowly engage the clutch. The vehicle should not move. For automatic transmissions, you also bring the apparatus to a stop, set the parking brake, and allow the engine to idle. Shift to neutral and operate the pump shift control. Now, shift into the correct gear for pumping. To check that the shift has been completed, gently press on the accelerator. The vehicle should not move. Notice that the speedometer will read about 5 to 15 miles per hour or 10 to 25 kilometers per hour, even though the vehicle isn't moving. To disengage a midship transfer-driven pump, use the throttle control to reduce the engine to idle speed, disengage the clutch, or place an automatic transmission into neutral. Wait for the pump drive shaft to stop spinning, and then operate the pump shift control from the pump position to the road position. Notice that the light on the dashboard goes out. Whatever pump position or transmission you are working with, once you have put the fire pump in operation, you will need to leave the cab to actually start pumping water. Chalk the wheels and then go to the pump panel. Open the tank to pump valve completely. If it has a locking mechanism, lock it in the open position. This will prevent vibration or an unintentional bump that could close it, cutting off the flow of water. Once the valve is locked open, the pump will fill with water. A multi-stage pump requires you to set the transfer valve to the proper position before pressure builds up in the pump. In most cases, when operating from the tank, the pump should be set in the series or pressure position. However, you should set the pump to the parallel or volume position if the pump will be required to furnish more than 50% of its rated capacity. This prevents having to shut down later to make the changeover from the series position. If the pump has been drained, it will be full of air. This air will have to be forced out by the water as it enters. Open the tank to pump valve or one of the discharge valves to allow the air to escape from the pump. Once the air is out, the discharge pressure can build up. In rare cases, it may be necessary to operate the primer to speed up the air removal process. The operator should increase the engine RPMs by using the hand throttle while observing the pressure gauge. If the pump is full of water, the pressure gauge should start to rise as soon as the RPMs increase. If no attack lines are ready to be charged by the time the pump pressure is built up, the pump-to-tank valve, sometimes called the circulator or tank fill, can be partially opened to allow water to circulate. If the hose lines are ready for water when the pressure is set, open the discharge valve slowly and lock it into position. Fire flow has begun. Set the automatic pressure regulating device or relief valve for the operating pressure. These devices will automatically adjust for excess pressure if it rises above the set limit. While the pump is in operation, carefully observe all engine and pump gauges. Be ready to take action to remedy any abnormal reading. Watch the water level in the tank. As the level drops, warn the officer in charge of the amount of water remaining in the tank.
2 minutes water left, 2 minutes.
You should be able to give an estimate of the amount of time that the water in the tank will last at the present rate of consumption. As the water in the tank is depleted, an external water supply may be required. The transition must be made without disrupting the fire attack. The supply line should be connected into an intake fitting of the pump, while the gate valve remains closed. There will be air in the empty supply hose that will cause problems if it enters the pump while the pump is supplying attack lines under pressure. To purge the air, open the bleeder valve on the gated intake so the air can escape as the supply line fills with water. When all the air has been forced from the line and a steady stream of water comes from the bleeder line, close the bleeder valve. You are now ready to make the transition. Open the intake valve slowly while closing the tank to pump valve. When enough water is available, divert some through the tank fill line to replenish the supply in the tank. Adjust the engine throttle to achieve the desired discharge pressure if necessary. A hydrant is one type of external pressurized water supply. When operating pumps from a fire hydrant, maintain close attention to the compound intake gauge and take prompt action if the pressure drops to near zero. If the flow is increased beyond system capabilities, the pressure in the system can drop below 0 pounds per square inch. Negative pressure is dangerous. because it increases the possibility of damage to the fire pump and water system. Cavitation is a condition in which vacuum pockets form in the pump. The pockets can cause vibrations, loss of efficiency, and possible damage. Cavitation occurs if you attempt to discharge water faster than it is being supplied to the pump. Air cavities or bubbles are created because there is not enough water in the pump. These cavities move through the pump until they collapse or fill with water. The speed of the water moving in to fill the cavities as they move from the intake to the pressure side of the pump causes a severe shock which will damage the pump. Cavitation can be recognized by fluctuating hose streams and a popping or sputtering sound as the water leaves the nozzle. In severe cases, the pump will sound as if gravel is passing through it. To avoid cavitation, maintain the incoming pressure above 20 pounds or 140 kilopascals per square inch. The steps to operating a pump from a hydrant are: choose an appropriate hydrant and make the proper hose connections. Check that the tank-to-pump valve is closed if the intake is not equipped with a shutoff valve. Make sure that the hydrant is opened all the way. If there is a transfer valve, set it before building up pressure. Since the pump on the hydrant is usually called on to supply large amounts of water, a good operating practice is to set the valve to the parallel or volume position. After the pump is full of water and the pressure in the system is stabilized, a reading of the pressure on the master intake gauge will indicate the static pressure in the water supply system. This reading is important for estimating the capacity of the hydrant. The capacity of the hydrant will determine whether additional hose lines can be supplied, so it is wise for the operator to write down this reading before the operation begins. Open the discharge valve slowly. Since the lines are empty, they must fill before pressure can be established. When the lines are flowing with the nozzles wide open, observe both the intake and discharge gauges while you increase the engine RPMs. If the master intake gauge drops below 20 pounds per square inch, or 140 kilopascals, do not open the throttle any further because cavitation could occur. If there is adequate supply, advance the throttle until the desired pressure and flow have been established. Set the relief valve or governor. When shutting down hydrant operations, be sure to smoothly and slowly close down valves to avoid water hammer and pressure surges. Slow the engine RPM to reduce discharge pressure. Shut off the pressure control device if you are using one. Slowly close the discharge valves. Put the road transmission in neutral. Disengage the pump. Completely close the hydrant to prevent damaging it. The last turn of the operating nut opens the drain holes in the base of a dry barrel hydrant, allowing the water to drain out. This is especially important in areas where there are freezing temperatures. All fire department pumpers should be able to pump water from a static water supply. Successfully operating a pumper from draft is one of the most challenging tasks required of pump operators. It requires a thorough knowledge of the principles involved in drafting, as well as familiarity with the apparatus. In drafting operations, an important consideration is how to get the water to the pump. You can offset the pull of gravity by creating a vacuum in the pump and intake hose that will reduce the atmospheric pressure in the hose. The amount of vacuum that will be required to overcome the differences in elevation depends on the height of the lift. The higher the lift, the greater the amount of vacuum required. The maximum amount of vacuum that a fire pump is required to develop is approximately 22 inches. A reading approaching this figure warns you that the pump is getting close to its maximum ability to perform drafting operations. Remember that if you attempt to increase the discharge from the pump beyond the point of maximum vacuum on the intake, cavitation will occur. The steps in operating the pump at a draft site are: position the pumper and immobilize it with the parking brake and wheel chocks. If the pumper is close to a road, leave the warning lights on. Connect the hard suction hose and strainer. Make sure they are airtight. Fasten a rope to the end of the strainer to help you position it correctly in the water. Be sure that they are sufficiently submerged in the water. From inside the cab, operate the pump drive system shift and place the road transmission in the proper gear. The pump will begin to turn. On automatic transmissions, make sure that the indicator light that confirms the disengagement of the rear axle is lit. Any unwanted movement of the apparatus is especially dangerous in drafting operations. Before priming, make sure that all drains and valves are closed and the pump is as airtight as possible. If you have a two-stage pump, place it in the parallel or volume position during priming. Set the engine to the RPMs recommended in the operator's manual. This is usually around 1,000 to 1,200 RPM. Operate the primer control. As air is evacuated from the pump, notice that the intake gauge will register a vacuum reading. This reading should be 1 inch for each 1 foot of lift. When the body of the pump fills with water, the primer will discharge water on the ground under the apparatus. Keep the primer engaged until it is discharging a steady stream of water. Once the pump is primed, increase the setting of the throttle to boost the pressure to somewhere between 50 and 100 pounds per square inch. Open a discharge valve slowly while observing the discharge pressure. If the pressure drops below 50 pounds per square inch, pause to allow it to stabilize before opening the valve further.